Basically, there is a very important relationship between the average costs and the marginal cost. They indicate you where you are minimizing your cost, which is really important. And the idea a little bit is that where should you produce? When should you stop producing? Is it feasible and profitable to produce at this point? Obviously, you see the market price at which you are selling your units, and you have the numbers of your cost structure. No, basically you know your different types of costs, and you compare at what price can you sell, what type of cost do I incur, and that relationship between the marginal cost and the average cost indicates you more or less where are you, what ranges of prices are you safe to produce and earn money, or where you should stop producing. And this a little bit this last idea with regards to cost. So a couple of things here. Number one, in the short run, basically the firm's individual supply curve is essentially their marginal cost curve from the point it starts to produce. Because you can, like any rational firm, will not produce at any price, obviously, because if the price is too low, you will not cover your costs. So it makes no sense to produce at that particular price, unless you're Lopez Obrador and the current government, and you know that, and you want to produce with Pemex, whatever the cost. But normal firms would lose money, so they would not produce at any price. From the point you start producing onwards, the marginal cost, the shape of that marginal cost curve is essentially the supply curve of that individual firm. The one that you saw at the beginning of the course, that like increasing upward sloping supply curve was essentially the individual marginal cost curve of that firm we were discussing. So this is more or less how the different average cost and the marginal cost are graphed. We saw these particular graphs or curves individually at the last class. Now, if we combine them, as we see here, we see three curves. The yellow one is the average variable cost. The blue one is the average total cost. And the red one is the marginal cost. The yellow one describes the cost per unit, the variable cost per unit. The blue average total cost curve is what is the cost per unit, the average cost per unit. And the marginal cost is what is the additional cost for every extra unit I decide to produce. The x-axis of this graph is the quantity that you're producing, from 0 to the left to infinity, or a very big number to the right. And the y-axis is basically just money. So as you see, there are 2 points there. And what happens in most firms is that the marginal cost normally intersects both the average variable cost and the average total cost at their minimum points. And that particular intersection is important to remember because it signals specific moments within the production of the firm that should be taken into account. It signals two things: the shutdown point and the break-even point. The average variable cost and the intersection with the marginal cost, the first point where it says minimum AVC, shows you the shutdown point of a firm. Where should the firm stop producing and shut down the factory? Not exiting the market, still continue to exist as a firm. But like right now with the COVID, where they have to shut down and have no people working, they still have to pay the rent and the things like that basically they own there. But they are not paying for their workers normally. And the minimum ATC point, where the marginal cost intersects the average total cost, is the break-even point of a firm. It's basically where is the minimum quantity in terms of the x-axis, where as a firm, I am not losing money. I'm not getting any profit, I'm just breaking even. Those two things are really important to remember. On the yellow one, the minimum AVC, you are losing money. You are losing the cost of the equipment, of the factory that you're renting, or the space or the land, the office space, those things that you need to have before producing. But that if you decide to not produce any unit for that month, you will not pay for the variable cost. But in the minimum AVC, which is the shutdown point, you still pay for your fixed costs. So let me show you a little bit of this. So this is a little what we were discussing. In particular, the point at the bottom of the screen that reads the shutdown point. This is a very important place because it is the point where you decide to stop producing. And understanding that can help save a firm when it's losing money, because if the price goes too low, every unit you keep producing will only mount up your costs. So you don't want to like have rising debt or rising costs that you can't afford and losing money every month. So it's better to basically, it's an idea of like, let's cut the losses, and you cut the losses by stop by halting production. The shutdown point is the moment you decide to stop producing an output. So this is the shutdown point. The shutdown point, as it says in the particular slide or in the particular graph, is the minimum AVC from two graphs ago or two slides ago. That point, the minimum AVC, the minimum of the variable of the average variable cost, is also known as the shutdown point. That's the point where the firm is preferable for the firm to shut down operations, absorb the losses of the fixed cost, than actually producing, because every unit produced would lose money. And that's why it's called the shutdown point. And the explanation for that is here, and it involves a little bit of what we were just discussing regarding profits. So any firm that wants to maximize profits has this particular, this is a general function of a maximization problem for profits. Pi y is the symbol used for profits. So profits equals the revenues, P times Y, precio por cantidad de vendida, minus the total cost that we have already discussed. You can decompose the total cost into the fixed cost and the variable cost. You want to basically maximize revenues and then subtract the fixed cost and subtract the variable cost. So essentially, if you are losing money every unit you're producing because the price is too low for your costs, it means that the variable cost, CVG, is basically dragging you down. So if you shut down the operation, you're not hiring anyone, you're not basically incurring in any variable costs. Therefore, that disappears from your equation, and now you're only focusing on the fixed costs. But if you're not producing, you can't have revenues. So basically, you can't also have the PY. So what happens here is this: you will decide to shut down if and only if the money, basically the number you get from producing and having some revenues, PY, and then subtracting the fixed cost and the variable cost, is bigger than the just absorbing the fixed cost. So you will produce any positive number of units only if this inequality holds. If producing is worthwhile. And if that's the case, you will produce. If not, just cut the losses and actually absorb the fixed cost and have no one within your factory or your offices for a time being while you restructure the firm. And basically this implies, as the slide indicates, that this only works if the price, if I do a little bit of algebra, basically, and I eliminate the f's of both sides because they're the same on the inequality, you're left with the py minus the variable costs. So this only applies if the price at which you're selling your product is greater than or equal to the variable cost, and that divided by the number of units. And that is the variable cost divided by the number of units is literally just the average variable cost. So returning to our graph from 2 slides ago, you will only produce if the price, if that line or that point is above the shutdown point, above the minimum point of the average variable cost. You can remember, breaking even is the point at which the blue line in this graph intersects the red one. The marginal cost intersects the average total cost. But there's a gap between the shutdown point and the break-even point. So remember that shutting down a firm is not exiting the market. You have not basically gone broke. You are at risk, and you should decide to basically shut down operations. But shutting down operations may be a rational business decision. With the oil example, is at what specific oil rigs from the different oil rigs I have as a firm should I just shut down operations and not produce there and only produce with the units that I am more profitable. In other types of chain stores, think of what specific store is not worthwhile to have open, and you shut it down and eventually close it, but you still operate in the other stores in which you are having a bigger profit. So that's the idea of the shutdown point. Exiting an industry implies more of a long run decision in which you are not finding any store or any business unit or any oil rig in which you are profitable. And eventually you will decide to basically just exit the market and stop existing as a firm. So what you want to find is the lowest level of your costs that you can find through the optimal quantities of all your inputs in such a way that you find different cost structures. You want to find the lowest cost structure possible, in this case, or in this graph, C prime, which is smaller or lower than the C double prime. You find the conditional input demand, in this case, the conditional input bundle, where you find the best, there we go, where you find the best or the best quantities of your inputs that allows you to reach the level of production you want, the red curve, at the lowest cost possible. That is essentially the cost minimization problem. That you can see this process, the mathematical process, in the appendixes of this lecture. Any questions before we finish and we head to the end of class evaluation?